Before getting started on this lesson, try the warm-up question. Calculate the perimeter and area of this composite shape. So pause the video, try it, and see how you do. I started by finding out the distance around this curved part of the shape. I noticed that it was a semicircle, so I used the formula for the circumference of a circle and divided it by 2. I knew that the diameter was 14 centimeters because this side is 30 centimeters, so I knew that the total had to be 30 centimeters on the other side too, so I just subtracted the 8 and the 8, and it left me with 14 centimeters. So when I calculated the circumference of this semicircle, it was 22 centimeters. So the perimeter was adding up all the sides, including the curved side, and it ended up being 88 centimeters. To find the area of this shape, I took the area of the large rectangle, which was 300 centimeters squared, and I subtracted the area of the semicircle, which was 77 centimeters squared. So the total area ended up being 223 centimeters squared. So up until now, we've been looking at two-dimensional shapes. We've been calculating perimeter and area. In this lesson, we're going to start looking at volume of three-dimensional shapes. This lesson focuses on prisms and spheres. First, we'll start with a definition of what a prism is. A prism is a 3D shape with two matching and parallel bases. So if you look at all of these shapes that I have on the screen, try to identify which of these are prisms and which are not prisms. Pause the video and try it on your own, and then check back in to see how you did. This shape here is a cylinder. It has a circular base and another circular base over here, and those bases are parallel to each other. So that's a prism. Here is a cone. It has a circular base, but it doesn't have a parallel circular base on the other side. So this is not a prism. Here we have a triangular base, and parallel to it is another triangular base. So that's a prism. That's a triangular prism. This is a sphere. It doesn't have any bases at all, so not a prism. Here's a cube. Has a square base, parallel to each other on both sides. So that's a prism. And that's a prism. Here's a prism. If you can see, it has a pentagon as a base, and parallel to it, another pentagon base. So that is a prism. Here we have a square base, but not a parallel square base on the other side. So that is not a prism. That's a pyramid. So you need to be able to identify what a prism is in order to be able to calculate the volume of a prism. To calculate the volume of a prism, you take the area of the base and multiply by the height of the prism. And that works for any kind of prism. For example, here we have a pentagon base on a prism. We would simply need to know the area of the pentagon. That's the area of the base. And we would need to multiply it by the height of the prism. And when I say height, I mean the distance from one base to the other base. Some units of volume are things like centimeters cubed, millimeters cubed, meters cubed, but we even have things like milliliters, liters, gallons even. In our class, though, we're going to focus on metric units of volume. Centimeters cubed, millimeters cubed, meters cubed, these are all cubed because of this. Area is, say, centimeters squared multiplied by another centimeter. So centimeters squared times centimeters. That's centimeters multiplied by itself 3 times. That's why it's centimeters cubed. Now these units of volume, milliliters and liters, these are more familiar when we're talking about containers that have drinks and such in them. And there's a conversion. An easy one to remember is 1 milliliter is the same as 1 cubic centimeter, or centimeters cubed. They are the same. So if you know that 1 centimeter cubed is the same as 1 milliliter, you can change between different metric units of volume. So for this example, you're asked to calculate the volume of each prism. So first, find the area of the base and multiply by the height of the prism. Use your formula sheet to find the area of the base, or you might have those formulas memorized by now. Use your formula sheet. If you need it, pause the video, try to calculate the volumes, and then check back in to see how you do. For each of these prisms, I've highlighted the base in green. So here we have a rectangular base. Here we have a triangular base. Here we have a circular base. The area of the base for the first one is length times width. The area of the base for the second one, well, it's the area of a triangle. We usually write base times height divided by 2. Now, to avoid confusion, I'm using an L instead of an H because I don't want to have 2 different H's. I can't use the same symbol for 2 different things. So I've just used an L here. So it's the same thing. The base times the height of the triangle divided by 2 is the area of the triangle. The base in this cylinder is the circle, area pi r squared. So if I take the area of the base and multiply by the height of the prism, I end up with length times width times height for the volume of this rectangular prism. And I end up with 400 centimeters squared. If I take the area of the base and multiply by the height of the prism, for this one, I end up with BLH divided by 2. When you plug in your numbers, you end up with 189 centimeters cubed. And for the cylinder, area of the base is pi r squared multiplied by h is pi r squared h for the volume. And you end up with 226.2 centimeters cubed. And if you flip your formula sheet to the back side, you'll notice that these volume formulas are given for these shapes. But I just wanted to explain how those volume formulas came to be. It's simply just what I've been talking about. It's the area of the base multiplied by the height of the prism. So we've talked about volume of prisms. Now we're going to switch gears and talk about something totally different. We're talking about spheres. So of course the sphere is not a prism. You can't find the area of a base and multiply it by a height. That makes no sense for a sphere. So pretty much you just have to rely on the formula. 4 pi r cubed divided by 3. Or you might see it written 4/3 pi r cubed. It's the same thing. So basically, you just have to know the radius of the sphere, which is the distance from the exact center of the sphere to the outside of the sphere. And if you know that, that's the only value you have to plug into this formula. You have enough to calculate the volume. So, for example 2, calculate the volume of this sphere. Try it on your own. Pause the video and see how you do. If you do this correctly, you should end up with about 14,137.2 centimeters cubed for this sphere. If you didn't get that you probably were typing this incorrectly into your calculator. And in which case you would have to ask for some help with that. Otherwise, feel free to move on to the practice questions.